Hey guys, as I told you yesterday, and like you can see, I am not here today, but I did kind of let you know that I was going to make this video so that you could finish getting the notes on section R8. So yesterday we left off talking about inequalities, and we talked about the linear and compound inequalities. And we briefly started talking about what absolute value inequalities meant. And so here's just kind of a refresher of the two main things. When you are deciding how to solve your absolute inequality, your very first step, as always when solving anything, should be to isolate. And in this case, we're going to isolate the absolute value bars. So you get the absolute value of something is either less than or greater than or equal to, less than or equal to or greater than or equal to some number. Okay, so the first thing you should always do is isolate. Then the really important piece is that you have to look at what sign you have and determine, is it going to be a less than or an equal sign, because then that determines if you're going to set up an and inequality or an or inequality. So remember, a less than sign means you're going to set up an and inequality. You're going to put the stuff in the absolute value bars in between the negative and positive values of that constant that's on the right. On the other hand, if your absolute value sign, or your inequality sign, is greater than, that tells us we're going to set up an or statement. When you set up an or statement, you're either going to be less than the negative, so you kind of flip the sign for the negative, or greater than the positive. So you got to look at that inequality symbol, which it might not necessarily be what it starts as, because as you're isolating the absolute value, it might flip. So you look at the sign right before you split it up. So let's look at an example here. So this one says, solve the inequality and write the solution set in interval notation. And we're also going to graph it. So I'm also just going to let you know that because this is a video, you can go ahead and pause it whenever you need to if you need more time to write things down. So I'm just going to kind of keep talking, knowing that you're going to pause it when you need to. So this is our absolute value inequality statement. First thing I need to do is isolate the absolute value bars. I got to get this alone. So the first thing I'm going to do is subtract the 2 off. So I get 3 times the absolute value of 5 minus x is less than or equal to 12. Then I have to divide the 3 off. So I'm going to get absolute value of 5 minus x is less than or equal to 4. And notice I did not flip my sign because I divided by a positive. So now I'm looking at this and I see that my absolute value bars are isolated. So now I am free to determine if I need an and statement or an or statement. And based on this being a less than means and. Okay? And land. So an and statement means I need to put my 5 minus x in between a negative 4 and a positive 4. And now I solve. So I'm going to subtract 5 from both sides, or all sides, and I get negative 9 is less than or equal to negative x is less than or equal to negative 1. And now my x is not alone yet, so I have to divide by negative 1. And this is going to flip my signs because I divided by a negative. And then we kind of talked about yesterday how leaving it in this form, where you start with the bigger number on the left, is bad form. So I'm just going to reflip everything so that from left to right, this is in order. So my final answer is x has to be in between 1 and 9 inclusive. So how would I say that mathematically? X has to be greater than or equal to 1 and less than or equal to 9. So let's go ahead and represent this now on a number line. So I have 1 and 9 are my points of interest. And now they're inclusive, so close dots. And since x has to be between them, I shade in between them. And then in interval notation, since x is trapped between 1 and 9, and they're both inclusive, I'm going to do bracket 1, comma 9. And there you have it. Okay? So let's go ahead and try another one now. Now, I initially don't even like this one right off the bat because the absolute value stuff and the variable is on the right. So the very first thing I'm actually going to do is just rewrite all this, flip it. So it's -3 times the absolute value of 2y minus 4 is less than -18. That's what that says. I just rewrote it so that my variable is on the left. And now I need to get my absolute value bars alone. So I'm going to divide off the -3. And when I do that, I get the absolute value of 2y minus 4. And now I have to flip my sign because I divided by negative, is greater than 6. Okay? So looking at this greater than sign, that means I need to set up an OR statement. So what does that mean? Okay. 2y minus 4 is going to be less than the negative, or 2y minus 4 is going to be greater than the positive. And now I solve them separately. So add 4, 2y is greater than -2, divide by 2, y is greater than -1. Or add 4 and you get 2y is greater than 10, divide by 2, y is greater than 5. Okay, so let's get this on a number line. My values of interest are -1 and 5. And these are exclusive, so that means open dots on both. Less than, I made a mistake somewhere, didn't I? Oh, I sure did. Hey, let's back this up a little bit. Look right here on the very first inequality. I need my eraser. I accidentally flipped my sign when I did my subtraction. So I gotta fix that because it doesn't make sense that I had both of them as greater thans. Okay, so you were probably watching that and wondering why I did that. These are less thans. Whew, okay, so y is less than -1. So open dot on -1, shade to the left. Or greater than 5, so open dot on 5, shade to the right. And it looks like ORs because they're going different directions. And now to write this in interval notation, since we have two intervals that are shaded, we need two intervals. So -infinity to -1, parenthesis, because it's exclusive, or 5 to infinity. Cool. All right, so that one's done. Ooh, sorry about the mistakes in that one. All right, next one. Okay, so let's look at this one now. And our first job is going to be isolating those absolute value bars. So we need to go ahead and add that 2 over. So when we do that, we get 6 times the absolute value of 10 minus 10p is less than 120. Oops. It should be 120. Okay, so then our next move is going to be to divide off a 6. And we get the absolute value of 10 minus 10p is less than 120 divided by 6 is 20. Right, 12 divided by 6 is 2, so 120 divided by 6 is 20. And now that we have them isolated, we look at what our sign is. So our sign is a less than sign. So that means we're going to set up an and statement. So when we do that, we're going to go ahead and say, an and statement means you're in between. Negative 20 is less than 10 minus 10p is less than 20. All right, so subtract 10 all around, and we get negative 30 is less than negative 10p is less than 10. And now divide everything by negative 10. And this is another one where now it's going to flip our signs. And now it's in bad form. So we want to rewrite this as flip everything. Negative 1 is less than p is less than 3. Okay, so let's put this on a number line. Our points of interest are negative 1 and 3. And what we have here is strictly less than signs. So open dots, and since p is trapped between them, we shade in between. And since we only have one interval shaded, our interval notation should only be from negative 1 exclusive to 3 exclusive. Okay, cool. Let's practice one more. Go ahead and write this down. Pause if you need to. First thing I'm going to do, isolate my absolute value bars. So subtract that 10 over. And so you get negative 10 times the absolute value of negative x minus 3 is less than negative 60. Now divide off a negative 10, and you get the absolute value of negative x minus 3. Flips the sign, because we divided by a negative, is greater than 6. So we look at our sign, it's greater than. So that means an or statement. So we're going to say that negative x minus 3 is less than negative 6, or negative x minus 3 is greater than 6. Okay, add 3. We get negative x is less than negative 3. Divide by negative 1, and we get x is greater than 3, sign flipped. Or add 3. Negative x is greater than 9. Divide by negative 1. X is less than negative 9. Sign flipped again, right? Okay, so number line. Points of interest. Negative 9 is to the left, 3 is to the right. And we have open dots on these because these are strictly greater than or less than. No equal to's. And if it's got to be less than negative 9, shade to the left, or greater than 3, shade to the right, we have what looks like ors. All right, now interval notation, we have two intervals, so two intervals shaded, so two intervals, negative infinity to negative 9, exclusive, or 3, exclusive, to infinity. And there's your interval notation. All right, cool. So that's absolute value inequalities. This last problem that we're going to take a look at is a word problem. And it says, for a recent year, the monthly snowfall in inches for Chicago, Illinois, for November, December, January, and February was 2, 8.4, 11.2, and 7.9 inches, respectively. How much snow would be necessary in March for Chicago to exceed its monthly average snowfall of 7.28 inches for these 5 months? All right, well, to get average, you add up all of the values and then divide by how many there were. So we had 2 in November, 8.4 in December, 11